Hey guys, I hope you're well. Before I get started, if you see any strange bright flashes during scene transitions, I'm working with my video editor. I've had a problem creep up, a few months ago, and I'm convinced now, I've done some reading on the matter, and I'm convinced it's because of a software upgrade to this phone. So we'll see how it goes. I have read about a couple workarounds, so we'll try that. I'll try that. You won't be. I will be. I guess I am a ham, aren't I? It's always, we're working on a new antenna here. It's like, oh, really? Is your wife helping you, or maybe your 3-year-old? But I digress. Guys, I hope you're well. Aaron asked what a dim bulb tester does. And boy, I realized I take a lot for granted. My world is a strange little one. And, so I want to talk about that real quick. I'm going to talk to you a moment about what a dim bulb tester is and what it does. And while I do that, let me pause you and zoom you in on the schematic so you'll have something else to look at. One moment. Okay. Let me get a pointer. Oh no. Oh no. Oh no. Let me walk you through the schematic real quick, okay, guys? Over here, you have your AC in. This will be your power cord and your power plug. You have a 1 amp fuse. You have the main on-off power switch for the device. Then I have a switch that can select either of 2 lamps or both of them in parallel. And finally, we have a switch that will short out the lamps and their associated switches, which will thus apply full power through the amp meter to the outlets. Okay? And basically, this is the star of the show right there, the amp meter. Because, well, for many reasons. We'll talk about that in a moment. I considered some future mods. I considered mounting a little red LED next to each lamp that would light up when that lamp was selected, whether that lamp starts glowing or not because of your load. You select lamp 1, the red LED lights. Similarly with lamp 2. Considered that. Don't know if I will. This LED and this resistor down here are for a little LED strip light that I scavenged out of, that's just black tape wrapped around there. A little LED cob light strip that I'm going to be mounting on the meter so that the meter illuminates. And that meter illumination LED strip comes on as soon as you turn on the main power. Turn on the main power, boom, the meter lights up bright white. Okay, I'm considering those. Should I mount a red LED in front of each lamp holder, for example? I'll show you the LEDs that I have in a moment. Okay, what is a dim bulb device? Simply put, it's a current limiter. It limits the maximum current that can flow through your device under test to the current draw of whatever lamp you've selected, or both of them at the same time. Okay, I've written it down here. Let me pick this up and show you. Sorry about the video production or lack thereof. If you have the 43 watt lamp in series with your load, the maximum current that can flow is 0.36 amps. For the other lamp, it's 0.59 amps. And that you have some control over that. 43 watts is a pretty high wattage lamp for some radio work. More appropriate values would be a 25 watt lamp and a 60 watt or a 40 watt. But whatever, this works. And if you select both lamps in parallel, that's 115 watts. You'll see you've just gone over the fuse rating of this device, and it'll be fine. The fuse will not blow if you draw max current through this device. Okay, let me turn this back around and talk. Yeah, for a chance I get to talk and not feel guilty about it. So a dim bulb device is a current limiting device, but it's much more than that. I'll demonstrate to you guys that I can short circuit this output plug socket with a direct short. What happens when you do that? Well, all you do is light the lamp to full brightness and you flow this much current through the shorted plug. So that should be a good clue as to what this is capable of doing for you. And when would you use a device like this? Well, when first applying power to a piece of very old equipment that has electrolytic capacitors in it or potential other shorts. Electrolytic capacitors love to go bad. Their lifespan is shockingly short. Even modern electrolytics are going bad. Off to the left here is my Heathkit IP2718 tri-mode power supply. I just recapped it. And I'm going to make a video about that, a quick video, a short one, showing what I've done to it, what I found wrong with it, and what I've done to it. And that's not a restoration. That's just to get it working, repair on that machine, because it's a piece of my bench equipment. It's my servicing / test equipment. So I feel no need to do any kind of restoration on a piece of bench equipment made by Heathkit or otherwise. So, where was I? Okay. You take a radio that hasn't been turned on in 75 years. You think you're taking a chance with those electrolytics? You know, and at best, when you do that, if you were to take a radio like that with dead electrolytics, and when I mean dead, I mean a dead short. You take a radio like that and just plug it in. What happens? Well, you're gonna get fireworks, man. But beyond the fireworks, what have you done to the radio? Well, you found the low impedance sources, or sinks, I should call them. Sourcing current versus sinking current, that's a topic of discussion. Anyway, you found the short circuits when you plugged it in, and you've probably scared yourself to death and blackened your outlet in your home. But what if the radio has a power transformer in it? Now what have you done? Well, you may have destroyed the machine. You may have destroyed an irreplaceable power transformer. And so what can you do to avoid that? You use a dim bulb tester, either on its own. It's great for that. It's great for that. You plug a radio into this machine, even with full power, 120 volts supplying this machine. You plug a radio into this bugger that's got shorted electrolytics. I don't care if it's got a power transformer or not. What's going to happen? You light the light bulb. And interestingly, if you were to do that and the capacitors are not a dead short, but they're bad, what'll happen? Well, the light bulb you've selected will come on really bright. It'll come on really bright. And as that capacitor starts coming back to life, the light bulb will dim down. It'll dim down. And you can watch it and you get a feel for how that machine is behaving based on the dimming of that light bulb. But this machine can do so much more because of that amp meter. Because of that amp meter, when you power on, let's say I plug in my Crosley antique radio that's been restored. I plug it in, let's say I turn this on, give it full power, just so that we can watch its current draw at full power, and I turn the Crosley on. What happens? Well, the amp meter will go up because of the cold filaments in the tubes. It'll go up, it'll come back down as the filaments warm up, and as the power supply starts generating B+ voltage, high voltage, and the different stages in the radio start conducting, you'll see the current start crawling back up slightly. That's typical and expected behavior on a piece of vintage vacuum tube equipment, a radio receiver. Okay, so it can do that for you. An even better way of using it when you are to power up a device for the first time after many, many decades is to use your Variac, your variable AC transformer. You know what I'm talking about, I'm sure. I'll point you at one if I think about it when I take you off the tripod. You take your Variac through an isolation transformer, and I'll show you one of those as well on my bench. Why the ISO transformer? So that you don't kill yourself with electrocution, so you don't apply so much juice to your body that you die. Because many vintage vacuum tube radios, especially the All-American 5 variety that don't use a power transformer, they have what's called a hot chassis. Touch that chassis and touch ground and bye-bye Charlie. And so you feed the output of your isolation transformer into your dim bulb current limiting device. And of course you plug your device under test into that. And by doing that, you get all the benefits of a dim bulb tester with the added advantage that you can start at 0 volts and watch the current meter, select your lowest wattage bulb, keep your eye on the current meter, flip it on, start applying voltage with your Variac. Watch the current. Watch the current. If you've got a dead short, that current will start rising faster than you'd expect. And what else will happen? Your lamp will start lighting. As you increase the voltage, the more voltage you give it, the more the lamp brightness increases. The brighter the lamp gets. And if you keep increasing your Variac until you hit 120 volts and that lamp looks like it's pretty full bright, you've got a dead short. And the key being, you've got a dead short, but you've limited your current flow to that through that device. Okay? I hope that makes sense. Let me see what I'm forgetting. These LEDs I've got, they light up just dandy, anywhere between 15 and 30 milliamps. And so I forget what current I based it on, 30 milliamps or 20, but R1, that resistor can be 5.6K to 6.8K, and you should get about 30 mils or 20, depending on what value I used when I calculated that, through the LEDs. Okay. Let's see, what else? Okay, I'm going to pause you for a minute and show you a couple examples. Okay, I've got a pile of these 12, they call them 12 volt LEDs, 12 volt DC LEDs. They've got a dropping resistor in them already, but I'll need to use an additional one to run them on 120 volts AC. And You can't really tell because of my lights. They're actually pretty bright. Nope, the camera does. To my eye, that's very, very bright. And to the camera, it doesn't even appear lit. That's shocking. Dear God, that's shocking. To my eye, that is lit bright red. Wow. Anyway, what say you, man? And you can see that LED is drawing 5 mils at 7 volts. And that's what I did my calculations on, using 7 volts and 5 mils when I calculated the dropping resistor for that LED. So, boy, I don't know if I wrote down the value of the dropping resistor needed for that LED or not. Let me look real quick. The meter cob LED strip needs a dropping resistor of 3.9K. These red LEDs, 22K will work a treat. So, would you put them on there? Let me get this meter out of your face. Would you? And the problem is, I can't mount them above any of the switches. Like, I can't mount it here to denote that that switch is active, because the switch is on the other side of that panel. They'd have to go in between switches, which would look stupid, or there's nowhere else for them above the meter. But would it be more appropriate to mount one right in front of each? Here, man, let me pick you up. What would you do? Would you? If you did that, turn the power on, select your low wattage load, boom. Light lights up in front of that. Select this one, boom. That one does. Select both loads, they both come on. Would you? Would you? Hang on. Okay, guys. I plugged my Weller 25-watt soldering pencil into the dim bulb device and connected the Fluke AC voltmeter to the device. I've selected the 40-watt lamp right there where my finger is. Let me turn this meter, I keep bumping things. I've selected the 40-watt lamp. Now this soldering pencil draws 25 watts. It's operating normally. It's not turned on yet. The voltage you see on the meter, on the DMM, is just stray voltage. Watch, I'll grab the leads with my hand right now. See that? Just stray voltage because of the high impedance of these meters. What do you predict will happen when I turn the dim bulb device on and apply power to this outlet over here through the 40-watt lamp? Here, let's turn the power on, and you'll see that the voltmeter is now indicating 121 volts, which you'd expect. I've got no load on this thing. I'm reading the voltage through that lamp with no current flow. What do you think will happen when I turn a soldering station on? Do you think the light will come on? I say either very, very dim or not at all, because we're drawing so little current through the dim bulb device because we don't have any shorts. We don't have any heavy loads. Here we go. You can see I've turned the soldering pencil on your right, and the voltage didn't drop. Watch this. Let me turn this switch on and apply full power to the load. Watch the voltmeter. Here we go. Came up 1/10 of a volt. I'm dropping 1/10 of a volt through that lamp, maybe a couple tenths of a volt. And we've energized the soldering pencil normally. Okay, I'm going to pause you and reconnect. I'm going to pause you and plug my 140-watt Weller soldering gun in, and I'll bring the lights back up a little. Hang on. Okay, guys, I've plugged my 140 watt soldering gun into the device right here. The device is turned on. The 40 watt lamp is selected. Look at the AC voltmeter. I'm going to pull the trigger to the first position on this soldering gun, which is the high wattage setting, 140 watts. Now I've got a 145 watt load applied to the output of that 40 watt lamp. Which do you think will get more power? What do you think the light bulb will do now when I pull the trigger? Do you think it'll light up? Oh, I guarantee you it will. Watch. In 3, 2, 1. There you go. Now you can see a couple things. We've lit that light bulb up pretty darn bright. Is it full brightness? Doesn't look like it to me. And in fact, I know it's not. Look at the voltmeter. That's the voltage I'm applying to my soldering gun right now. Let's do it again. Let me block. Look at the soldering gun. Look at the light on the nose of it. It's barely lit. That's bright. Look at the fluke. I'm applying 36 volts to that soldering gun and barely powering it up. Look at, boy, I'm going to zoom you in on the amp meter on the dim bulb device. One moment. I never paused you. Sorry. Hey, man. It's 3:27 in the morning. Cut me some slack. Yes, sir. No, sir. I am haunted. I cannot sleep. I'm not well. I shut up. I quit babbling. I pull the trigger. Why do I talk like that? It's Philippe. I'll tell you about Philippe someday. Okay, watch the amp meter. Well, let's see how much current I'm flowing through my soldering pencil. There we go. 0.3 amps. Will it flow? Now let me pause you. Hang on. I'll pause you and zoom you back up. Pause you. There we go. Let's try that again. 0.3 amps. I'm only applying 35 volts to my soldering pencil. Let's pretend it's an antique radio. What happens if I choose the 70 watt load? You think that 35 volts will go up? Now we're applying 53 volts to the load, to the radio, if you will. Okay. If you have a Variac, you can increase voltage slowly to reform caps. If you don't have a Variac, about all you have, and all you have is this dim bulb device, you select your low load. You let it cook for a few hours. Turn the low load off, turn the high load on. You've applied even more voltage to the device under test, to the radio. Let it cook for a couple hours. Select both loads. Remember, 55 volts, select both loads. Boom, now I'm applying 73 volts to the device under test. And my soldering pencil, the light's much brighter now. It's starting to power up. Sorry about pulling the trigger on and off, right? The ammeter on the dim bulb device, 0.6 amps now. Okay, let it cook for a few hours. Apply full power to the device under test. You see the lamps have gone out because they're no longer in series with a load. I feel my right hand buzzing because my soldering gun just came alive. It's roasting as we speak. I'm applying 119.3 volts to the device under test. I'm going to let it go because it's roasting. 119.3 volts. We only lost 1.4 volts through this machine. Not bad, considering that I wired the whole damn thing with light gauge hookup wire. To make it easier to assemble. One moment, I pause you. One last, man, I did you wrong. Hang on, I pause you. Yeah, oh boy. Oh dear God. Oh, you can't see that? That was a smart move. I pointed you at my clock to prove the time. Well, I gotta edit this nightmare, this car crash of a video. That'll take me to about daylight. Then I can go to bed. Hang on, we're going on a field trip. Leave it. Blitzy, say bye-bye. Say I love you. Good night, guys. I hope you're well. Bye now.